Welcome to MSExamLab. This is PL-300 Power BI Data Analyst. Episode 4 Power Query Transformations. 16 Real Exam-Style Questions. Every answer key has been checked against Microsoft Learn before it reached this video. Where the question bank is wrong or its wording has been retired, I say so on screen. 16 questions. Merge against append, unpivot, split, error handling, profiling, and the transforms that cut load times. Question 1 of 16, merge versus append. You use Power Query to import two tables named order header and order details from an Azure SQL database. Order header relates to order details by a column named order ID in each table. You need to combine the tables into a single query that contains the unique columns of each table. What should you select in Power Query Editor? Your options: A. Merge queries. B. Combine files. C. Append queries. Pause here if you need longer, 10 seconds. The answer is A. Merge queries. Merge is a join. It matches rows on a shared column, order ID here, and brings the other table's columns in alongside. That is exactly what the unique columns of each table describes. Now, why the others fail. Append is a union. It stacks rows and needs matching columns. It adds height, not width. Combine files is for binaries pulled from a folder, not two database tables. One more thing, the keyword test for the whole episode: columns means merge, rows means append. Verified against Learn Microsoft.com merge queries overview append queries. Question 2 of 16, widening a table. You import two Excel tables named customer and address into Power Query. Customer has customer ID, customer name, phone, email address, address ID. Address has address ID, address line 1, address line 2, city, state, region, country, postal code. Each customer ID is a unique customer. Each address ID is a unique address. You need one row per customer that includes city, state, region, and country. What should you do? Your options: A. Merge the customer and address tables. B. Group the customer and address tables by the address ID column. C. Transpose the customer and address tables. D. Append the customer and address tables. Pause here if you need longer, 10 seconds. The answer is A. Merge the customer and address tables. You want extra columns beside each customer, so this is a join. Merge on address ID, expand, and pick city, state, region, and country. Row count stays at 1 per customer. Now, why the others fail. Append stacks rows. You would get customers and addresses as separate rows, not one row per customer. Group by aggregates and collapses rows. It destroys the detail you are trying to add. Transpose flips rows into columns. It is for badly shaped exports, not joins. One more thing, the keyword test, again, more columns means merge, more rows means append. Verified against Learn Microsoft.com merge queries overview. Question 3 of 16, deduplicating two sheets. You have an Excel workbook with two sheets. Sheet 1 contains a table named Table 1, and Sheet 2 contains a table named Table 2. Both hold a products column with overlapping values. You need to use Power Query Editor to combine the products from Table 1 and Table 2 into a single table that has one column containing no duplicate values. Which 3 actions should you perform in sequence? 5 actions, you need 3 of them in the right order. From Power Query Editor, remove errors from the table. From Power Query Editor, select Table 1 and then select Remove Duplicates. From Power Query Editor, merge Table 1 and Table 2. From Power BI Desktop, import the data from Excel and select Table 1 and Table 2. From Power Query Editor, append Table 1 to Table 2. Pause here if you need longer, 10 seconds. The correct sequence is: 1. From Power BI Desktop, import the data from Excel and select Table 1 and Table 2. 2. From Power Query Editor, append Table 1 to Table 2. 3. From Power Query Editor, select Table 1 and then select Remove Duplicates. Get both tables in first, then append to stack their rows into one column, then remove duplicates from the combined result. Order matters, dedupe before the append and the cross-stable duplicates survive. Now why the others fail. Merge would put the two product lists side by side as separate columns, not one column. Removing errors addresses a different problem. Nothing here is an error value. Deduplicating before appending only cleans each table individually. Verified against Learn Microsoft.com append queries remove duplicates. Question 4 of 16, joining dirty text. You import two tables named Customer and Contacts. Customer contains customer name, customer ID, and website. Contacts contains contact ID, contact email, contact name, and customer name. A web-based contact form fills the contacts table and the data is not sanitized. You need to create a merge between the two tables on the customer name. What should you do? Your options. A. Set join kind to full outer. B. Disable fuzzy matching. C. Set join kind to left outer. D. Enable fuzzy matching. Pause here if you need longer, 10 seconds. The answer is D. Enable fuzzy matching. Unsanitized form input means the same customer arrives with different spelling, casing, and stray spaces. Fuzzy matching compares by similarity rather than demanding an exact string match, so those near misses still join. Now why the others fail. Disabling fuzzy matching is the opposite. Only exact strings would join and the dirty rows would fall out. Join kind decides which unmatched rows are kept. It does nothing about whether two spellings are treated as the same value. One more thing, fuzzy matching works on text columns only, and you can tune the similarity threshold. Verified against Learn Microsoft.com fuzzy merge in Power Query. Question 5 of 16, years across columns. You import and preview sales data for 2020 and 2021 from an Excel file. The years sit side by side as separate columns. You need to shape the query to display 3 columns, month, sales, year. What should you select in Power Query Editor? Your options. A. Merge columns. B. Transpose. C. Unpivot columns. D. Pivot column. Pause here if you need longer, 10 seconds. The answer is C. Unpivot columns. Year values have been used as column headers, the classic crosstab. Unpivot turns those headers into rows, giving you an attribute column for year and a value column for sales, with month intact. Now why the others fail. Pivot is the exact opposite. It turns rows into columns. It would make the shape worse. Transpose flips the whole table on its diagonal, wrecking month as well. Merge columns concatenates 2 columns into one string. One more thing, rule of thumb, if a value is acting as a column heading, you need unpivot. Verified against Learn Microsoft.com unpivot columns in Power Query. Question 6 of 16, first transform on a crosstab. You have a CSV file and preview it in Power Query Editor. You need to transform the data so that the first column contains the month, the second column contains the year, the third column contains the order amount for that month and year. Which transformation should you use first? Your options. A. Remove. B. Unpivot. C. Transpose. D. Pivot. Pause here if you need longer, 10 seconds. The answer is B. Unpivot. Same crosstab problem, and the question asks which comes first. Unpivot collapses the year columns into a year attribute column and a value column. Everything else is cleanup afterwards. Now why the others fail. Pivot would push data further into a crosstab, away from the target shape. Transpose rotates the table and does not produce an attribute value pair. Removing anything first risks discarding the very columns you need to unpivot. Verified against Learn Microsoft.com unpivot columns in Power Query. Question 7 of 16, one cell, many values. You have a query in Power Query Editor containing a classes column where each cell holds several class names separated by a delimiter. You need to transform the data so that each class appears on its own row. What should you do? Your options. A. Split the classes column into rows by using a delimiter. B. Unpivot the classes column. C. Extract the text between delimiters in the classes column. D. Convert the classes column into a list. Pause here if you need longer, 10 seconds. The answer is A. Split the classes column into rows by using a delimiter. Split column by delimiter offers a choice of columns or rows. Choosing rows duplicates the rest of the row for each value found, which is exactly one class per row. Now why the others fail. Unpivot works on multiple columns. Here the problem is inside a single cell. Extract returns just one fragment of the text and throws the rest away. Converting to a list gets you a list object per cell, which still needs expanding and is not an option in the UI here. One more thing, split by delimiter can go to columns or rows. Reading which one the question wants is the whole question. Verified against Learn Microsoft.com split columns by delimiter. Question 8 of 16, reducing a date to a year. You preview a column named Date in Power Query Editor. You need to change the date column to contain only the year. The solution must minimize administrative effort. What should you do? Your options. A. Split the column by delimiter. B. Split the column by number of characters. C. Extract the text after the delimiter. D. Transform the column to contain only the year. Pause here if you need longer, 10 seconds. The answer is D. Transform the column to contain only the year. Power Query has a built-in date transform, then date, then year. One click, it stays date-aware and it survives format changes in the source. Now why the others fail. Splitting by delimiter or character count treats a date as text. It breaks the moment the source format shifts and it leaves extra columns to clean up. Extracting text after a delimiter is fragile in the same way and produces text, not a number. One more thing, minimize administrative effort almost always points at a purpose-built transform rather than a string trick. Verified against Learn Microsoft.com date and time transformations in Power Query. Question 9 of 16, replacing error values. You preview data in Power Query Editor. Column profiling shows the discount column is 63% errors and its type is not numeric. You need to clean and transform the query so that all rows of data are maintained and error values in the discount column are replaced with a discount of 0.05. The solution must minimize administrative effort. Which 3 actions should you perform in sequence? 5 actions, you need 3 of them in the right order. Select the discount column. Select the price column. For the discount column, change data type to decimal number. For the discount column, change data type to whole number. Select Replace Errors to replace each error value with 0.05. Pause here if you need longer, 10 seconds. The correct sequence is 1. Select the discount column. 2. Select Replace Errors to replace each error value with 0.05. 3. For the discount column, change data type to decimal number. Select the discount column first. Replace errors acts on the selection. Replace the errors with 0.05 so no error values remain. Then set decimal number because 0.05 and 0.08 are fractional, whole number would round them away. Now why the others fail. The price column is not the one with errors, selecting it does nothing useful. Whole number would destroy the decimal discounts you just inserted. Removing error rows instead of replacing them would break the requirement to maintain all rows. One more thing, order matters. Replace the errors before typing the column or the type conversion trips over the errors. Verified against Learn Microsoft.com dealing with errors in Power Query. Replace values and errors. Question 10 of 16, reading a custom column error. You attempt to create a custom column and receive Expression.Error. We cannot apply operator and to types text and number. Details, operator equals and left equals a right equals 1. 2 selections here. The error is caused by. Choices are error values in the source data. Mismatched data types. Null values. The desired outcome of the custom column is. Choices are 1A. And 1. A1. Pause here if you need longer, 10 seconds. The answers are mismatched data types and A1. The message names it and got text on the left and number on the right, so this is mismatched data types. The intent was to concatenate into A1 and demands text on both sides, so convert the number first with text from. Now why the others fail. Source errors show as error cells in the column, not an operator type complaint. Nulls give a different message and usually yield null, not a type error. And 1 is the formula written out, 1A reverses the operands, neither is the value produced. Verified against Learn Microsoft.com dealing with errors in Power Query text from. Question 11 of 16, a broken step reference. You have a data model that imports from an Excel spreadsheet. You load a query containing both renamed and custom columns. Later, you reload the query and receive Expression.Error. The column category of the table wasn't found. What are 2 possible causes? This one wants 2 answers, not 1. Your options. A. The column was removed from the source file. B. The column was renamed in the source file. C. The file is no longer in the specified location. D. The data type of the column was changed. Pause here if you need longer, 10 seconds. The answers are A. The column was removed from the source file. B. The column was renamed in the source file. Power Query hardcodes column names into every step. If category is gone or now carries a different name, each step that references it fails. Removing and renaming are the same failure from the query's point of view. Now why the others fail. A missing file raises data source.error, not expression.error. The prefix tells you which layer broke. A changed data type gives a conversion error about values, and the column is still found. One more thing, prefix triage, data source.error cannot reach the source. Expression.error equals the source is fine, but a step points at something that is not there. Verified against Learn Microsoft.com dealing with errors in Power Query. Question 12 of 16, profiling and fixing a bad column. You are profiling data in Power Query Editor. A date column holds values like 2024-0207, and a column named Data Entries menu mount holds values such as 11-1900, 21-1900, and 1 error. Select the answer choice that completes each statement. 2 selections here. Before you can transform the date column to show only the day, you must. Choices are change the data type. Use the parse command on the column. Use the replace values command on the column. To fix the error displayed for the data entries menu mount column, you must Choices are change the data type, rename the column, use conditional formatting. Pause here if you need longer, 10 seconds. The answers are use the parse command on the column and change the data type. The date column is being held as text, so parse converts it into a real date before any day-level transform is available. The menu mount column is an amount that has been coerced into dates, which is a data type problem. Change the type and the error clears. Now why the others fail. Replace values patches individual values but never changes what the column is. Renaming a column has no effect on its content or its errors. Conditional formatting is a report-side visual feature and does not exist in Power Query. Verified against Learn Microsoft.com data profiling tools parse text as JSON or XML data types in Power Query. Question 13 of 16, cutting load time. You have a query named Sales. Users only use the date part of the sales date field and only rows with a status of finished are used in analysis. You need to reduce the load times of the query without affecting the analysis. Which two actions achieve this? Each correct answer presents a complete solution. This one wants two answers, not one. Your options. A. Remove the rows in which sales status has a value of canceled. B. Remove sales date. C. Change the data type of sales delivery time to integer. D. Split sale date into separate date and time columns. E. Remove sales canceled date. Pause here if you need longer, 10 seconds. The answers are A. Remove the rows in which sales status has a value of canceled. E. Remove sales canceled date. Cut rows nobody analyses and columns nobody uses. Canceled rows fall outside the finished only analysis and the canceled date column is only meaningful for those rows. Both shrink the load and neither touches the analysis. Now why the others fail. Removing sales date deletes a field users actively rely on. Splitting sale date adds a column, which increases the load rather than reducing it. Retyping delivery time is a marginal storage tweak, not a load time reduction, and it is not a complete solution on its own. Verified against Learn Microsoft.com data reduction techniques for import modeling. Question 14 of 16, less data, faster report. You have a semantic model containing two queries. A report based on the model has performance issues. You plan to use Power Query to reduce the data loaded to the model. Which two actions should you perform? Each correct answer presents part of the solution. This one wants two answers, not one. Your options. A. Apply group by and summarize techniques. B. Combine the queries by using Append. C. Remove unnecessary columns and rows. D. Combine the queries by using Merge. E. Create a new query group. Pause here if you need longer, 10 seconds. The answers are A. Apply group by and summarize techniques. C. Remove unnecessary columns and rows. Both answers reduce volume. Removing unused columns and rows is the direct cut. Grouping and summarizing raises the grain so fewer rows land in the model. Together, they shrink what has to be scanned at query time. Now why the others fail. Merge and append reshape data, they do not reduce it. Merge can even widen the table. A query group is a folder in the editor. It organizes your work and changes nothing about what loads. Verified against Learn Microsoft.com data reduction techniques for import modeling. Question 15 of 16, killing a per row API call. You ingest two SharePoint online lists named customers and locations. Each has more than 25,000 rows. Locations is referenced in customers to generate qualified values in a drop-down list. You experience long load times and discover that Power Query Editor makes calls to the URL of each referenced item. What should you do to reduce the load times? Your options. A. Read the lists separately and then merge the lists. B. Read the lists separately and then append the lists. C. Create a custom function to read the reference SharePoint list. D. Expand the reference column of the query. Pause here if you need longer, 10 seconds. The answer is A. Read the lists separately and then merge the lists. Expanding a lookup column makes Power Query fetch each referenced item one at a time, 25,000 separate calls. Load both lists as their own queries, then merge on the key. That is 2 bulk reads and 1 join instead of tens of thousands of round trips. Now, why the others fail? Expanding the referenced column is the cause of the problem, not the cure. A custom function still calls per item. You have wrapped the slowness, not removed it. Append is the wrong shape entirely. These lists relate, they do not stack. Verified against Learn Microsoft.com SharePoint Online List Connector Query Folding Guidance. Question 16 of 16, IoT Series 4 Solutions. Repeated Scenario Series, you profile IoT data in Power Query Editor. The IoT GUID and IoT ID columns are unique to each row. You need to analyze IoT events by the hour and day of the year, and the solution must improve dataset performance. For each proposed solution, does it meet the goal? For each statement, yes if it is true, otherwise no. Statement 1, split the IoT date-time column into a column named date and a column named time. Statement 2, remove the IoT GUID column and retain the IoT ID column. Statement 3, change the IoT date-time column to the date data type. Statement 4, create a custom column that concatenates the IoT GUID and IoT ID columns, then delete IoT GUID and IoT ID. Pause here if you need longer, 10 seconds. The answers are Statement 1, yes, Statement 2, no, Statement 3, no, Statement 4, no. Only the split meets both halves of the goal. Separate date and time columns give you day of year and hour to analyze by, and splitting a high cardinality data time compresses better, so performance improves too. A solution must satisfy every requirement, not just one. Now, why the others fail? Dropping IoT GUID helps performance but gives you nothing to analyze hours or days with. Changing date time to date throws the time away, so hourly analysis is impossible. Concatenating 2 unique columns raises cardinality, worse performance, still no date or hour. Verified against Learn Microsoft.com data reduction techniques split columns in Power Query. 6 things to carry into the exam. 1. Columns merge, rows append. Widening a table is a join. Stacking rows is a union. 2. Headings that are values. If a year or a month is acting as a column heading, you need unpivot. 3. Split can go to rows. Split by delimiter offers columns or rows. Reading which one is the whole question. 4. Clean before you type. Replace errors first, then set the data type or the conversion trips over them. 5. Fuzzy for dirty text. Unsanitized input needs similarity matching, not a different join kind. 6. Every requirement counts. In repeated scenario series, meeting one goal and missing the other is still no. That is Episode 4. Episode 5 is Data Quality, Profiling, and Data Flows. Column profiles, error triage at scale, and reusable prep with data flows and parameters. This series runs 20 episodes and covers the whole exam. Subscribe so you get each one as it lands. And tell me in the comments which question caught you out. I read them all. See you in Episode 5.